of the faculty program on sustainable and for this workshop, we have architect Ashika Sultana for eQuest training. Before we begin, I would like to notify the participants the usual instructions. All queries and doubts can be dropped or direct an audio session. I apologize for the technical difficulty. Good morning, all. Welcome to day 9 of the Faculty Development Program on Sustainable Development for Mitigating Climate Change. Yesterday, on day 8 of the FDP, we had with us Dr. Sunil Pandey, Dr. N. Shinde, and Dr. Saban Thapar with presentations on waste management, sustainable building technologies, and energy management, respectively. Today, for the Building Energy Simulation Workshop, we have with us architect Ashika Sultana for eQuest training. Before we begin, I would like to notify the participants of the usual instructions. Kindly switch off your audio and video during the sessions. Switch it on only upon the request of the facilitators of the FDP. This is to ensure smooth and undisturbed sessions. Kindly note that all queries and doubts can be dropped in the chat box or directly on audio during the sessions. A Google Drive has been shared in the WebEx chat box and the WhatsApp chat where the speaker will share essential documents. Kindly access the drive as is requested by the speaker. At the end of the day, a Google form for attendance will be shared in WebEx chat. Please fill it up to be marked present for the session. Kindly notify us if you don't receive the same for links. Introducing us, the speaker of the day, Ashika Sultana. She is a green building consultant specialized in sustainable architecture with an extensive experience in design and analysis of climate responsive and energy efficient buildings. She is a Griha certified professional, IGBC accredited professional, GEM certified professional, and an ECBC compliance expert, supporting practicing architects and designers to evaluate their designs based on green standards. She began her career in sustainability and green buildings from the Energy and Resources Institute and later engaged with green building design and facilitation of various green rated projects while working at Passive Design Consultants in New Delhi. She worked with Ella Green Buildings and Infrastructural Consultants as a sustainability consultant and All India Institute of Local Self-Government as a project officer for the implementation of Energy Conservation Building Code in Kerala. Presently, she is leading the team of Tropical Greenovation Cluster in analyzing high-performance building solutions and consultation for various green building certifications. She has participated and coordinated various national and international conferences related to energy efficiency and sustainable technologies. She has also appeared as a speaker and trainer for various programs conducted by government and private sector organizers related to sustainability and green buildings. We welcome you, ma'am, to the 8th day of FDP. Without further ado, let us begin the session.
Good morning, one and all, and thank you for ma'am for your formal introduction. And so I'm not speaking anything about myself. I'm directly jumping to the session. So before that, I'm having two polls, and I'm asking the coordinator to post the poll one first. Because all of you are going through an extensive program starting from the beginning of this climate change initiative by FDP programs focusing on climate change. So you have gone through, I was listening to the, description that the organizer was giving. So it was an amazing session. I'm assuming that, and let me tell you what I'm going to have today will be more like a practical aspects that we are going to cover, and I'll be discussing how we can quantify the aspects of sustainability, especially in terms of energy efficiency and carbon credits indirectly. So before I think that I'm audible to everyone.
Yes, Archika, you're audible. I'll just post the first poll now. Just give me a few seconds.
Sure, sure. And so presently we have 50 participants over here. So do we need to wait for someone else, or is it the number that we have?
Ma'am, maybe a few more may join in another 15 minutes. I think we'll start and let the others join as they come in.
Okay, fine. Okay. So actually, before starting the session, I just want to know the background of the professionals. I know all of you are teachers, and actually, I am very much excited to have this session today because I am discussing with teachers means I am conveying my idea to infinite number of people because you will definitely be discussing with your students, and it's as it's a hot topic, this energy simulation and the quantifying aspects of green building. So before starting the session, that's what I said. The poll has nothing. I'll explain to you. I just wanted to know how many of you are architects and how many of you are civil engineers, electrical engineers, and all. And because in the earlier sessions, maybe it was energy conservation was there, energy auditing procedure were there, and related to the topics, you must have heard of what is the real aspects happening in the industry, right? So here I'll be taking you through a simple example, like example of a building, and we'll expose the software eQuest, and let's know how we can, go forward and finalize, the final energy consumption of a building. Let me share my screen then. So let's have the presentation by the polls are getting ready. And meanwhile, I posted 2 documents in the drive. We will go for that after some time. So I hope my screen is visible to everyone, right? Let me share my presentation.
Yes, your screen is visible.
Good. Okay. So before starting the session, let me tell you some more things. Because as we are going through the software, all of you must have to follow me. Because I have actually divided the session into 6 parts. And the first one will be, we'll just discuss the basics of energy modeling. And then we'll go to the software, eQuest. And after discussing the procedure, workflow, and the parameters that we are going to address, we'll go to the subject sessions. They are building envelopes, lighting session, HVAC, and finally, we'll go through how we can develop, produce the result using the software, and how can we interpret the result. And you should have these two things throughout our session, okay? The first one is the connectivity. So if you lose the connectivity in between, you will, lose in between, and you may not be able to find out where we are standing. And the second one is that you have to be full on into the session, because here in between you may change the tools, and as building energy simulation is a complex process, you know that. And what we are trying to do is we are going to condense everything in the 8 hours. So today and tomorrow we are going to have 8 hours, 4 hours each. And so in this limited hour, we have to cover a number of things for sure. So I may not be, beating around the bush at anywhere. I'll be just, hitting the target. And for that, you have to be with us, throughout the session. And in between, if you feel any difficulties, you are free to post in the chat box. And after each of the session, we'll have the voice chat, and we'll discuss your questions, over voice. We can have a discussion sessions. I prepare for that as well. So these two things, make sure that you are full on looking into the screen, and the connectivity is stable. So let me start the poll then. So is the poll visible to your screen? Can you see the poll?
Yeah. Ashika, we can't. I think we lost a little bit of an audio in the middle. But now I think we can hear you. Can you please say something?
Actually, I did not start the presentation yet. Actually, I was giving some, advice, suggestions before starting the presentation. Because we need to be connected throughout, because in between, if they lose the connection, they'll lose the entire presentation. And as we have planned everything for the 8 and continuous 8 hours, you have to be with us. Okay. All question is not visible, it seems. I think I'm not able to post the poll.
Ashika?
Yes.
Yeah, we are not able to access the poll. If you go to the polling section again, do you see close poll or exit poll? Close poll. There will be an option at the bottom saying close poll.
Close poll is there, but it's inactive presently.
Inactive. So it's the same case with us. Let me just see what can be done. You may start with the.
Sure.
You may start with the presentation. I'll just post it and let you know. I'll just figure this out here.
Sure. Okay. Thank you.
Okay.
So let us start. And first of all, the term simulation must be new to at least, as all of your teachers, the term must be familiar to you. But still, when you heard of simulation, in real lifetime, you can relate it to many things. Okay, so what is the first thing comes to your mind, like when you say simulation? It must be the flight simulator game, right? That was the first simulation, that the term I heard in my life. And maybe there are many games like you must have gone through. If you're a football freak, definitely you know must be knowing this Football Manager. So all these applications are doing simulations. So what's the simulation? Simulation is if you say by definition, you must be creating something. We are imitating a system, mostly for forecasting what will be the prediction, what is the result that is going to have in the future. And why do we need energy simulation? Like in the case of buildings, why do we need simulation? Because why are we doing, I'm also assuming that majority will be architects, okay? As it's my assumption, because I want to quote about SketchUp. So all of us are using SketchUp starting from BIAST. So in SketchUp, why do we do SketchUp modeling? Why do we need a 3D modeling? So before the construction itself, we want to know that how our building model will look exactly. What is, its aesthetic value if we build that particular thing on the ground, or how is it responding to the surrounding. So all these factors we can understand, and also the property of that architectural properties like the proportion, the character, and the value that it has. So similarly, we need energy simulation for understanding the performance of building, the energy performance of the building before the construction itself. Because once after constructing, it's not easy to demolish and or alter to make it more performing. So that's the purpose of simulation. If you see the image on my screen, you can see for a factory building how does the simulation has happened. And also this is another office building, and how the real case and how the simulated thing has been made, and how the performance has been optimized. So this our major simulation or a building energy simulations can be done with the use of some software tools. And majorly, if you say energy simulation, it is associated with energy consumption, but there are many parameters which are affecting this particular energy performance. So first one is the envelope characteristic. So you can, okay, if energy consumption is your end product, okay, I'm having, chat. Send the poll again, it makes it few more. Oh, okay, carry on. And in between, so we were talking about discussing this. So energy consumption is directly linked to many other parameters. So the first one is the performance of our building envelope. And the second one will be the space loads, okay, the loads that's adding to your building. And active system involvement is another factor. And if we are going to work out on any energy conservation measures, okay, that will be another factor. And the life cycle cost of the building. Obviously, if we propose something, whatever it is, even if it's in a aesthetic case or it's in the performance end, the cost is a factor. So what is the life cycle cost? So all these kind of processes can be analyzed using the simulation softwares. And we will be discussing in detail what all these parameters and what are the factors affecting these parameters and how do we optimize them in the coming slides. So we know what is the global agenda. All of us know about the sustainability development goals that we need to achieve by 2030. And we know what is the priority that we are giving for energy conservation right now. Okay, the key factor is the climate change, so we need to mitigate the carbon dioxide concentration. And all of us know that in worldwide, not just in India, if you think about the worldwide scenario, we know how much carbon is getting emitted while we are producing energy, because most of our energy production methodologies are depending upon fossil fuels, and it is associated with global greenhouse gas emissions. So just imagine what is our what do you say, intention, because we are going to quantify and we are going to tell them, okay, what is the exact intervention in terms of number that we can say, okay, how much percentage of energy that you can save after constructing one particular building. So that forecasting or simulation in the beginning will be adding opportunities to a global huge goal. And if you think about our national scenario, we know energy conservation is the most priority, and our Ministry of Power has set up an energy conservation building code for the entire country. So this energy conservation building code is based on, India is having falls under different climatic zone, and you must be knowing different warm and humid, hot and arid, and cold climates are there, temperate is there, composite. So for all these classifications, there are different kind of benchmarks has been given under energy conservation building code. So this is our national thing, and let's go to the global again. So there are many green building analysis or evaluation systems available. So if you look into that, energy conservation is the major credit that is having more points. So for all these tasks, we need to prove what is the energy savings that you can make after your building design. So when you think about green building, as it's an integrated process considering the site factors and the building form and the materials or the skin and the systems, active systems that are using, HVAC design or plumbing design or electrical design. So all these factors are interlinked, and the effect of all these factors are, impacting the energy efficiency itself. So there can be direct impact and there will be indirect impact as well. And if you think about the share of energy consumption in a building, if you can think about commercial building, lighting constitutes most of the energy requirement, and HVAC comes second. And if you talk about a residential, fans or the air conditioning measures, air cooling measures will be costing more. So considering the scenario, actually energy conservation building code has implemented in commercial sector, considering the scenario, okay? And if you think about energy efficiency, there are so many means to achieve and energy efficiency in building sector. We know about the building components, right? So what all things are involved, and if we discuss about it starting from the design stage, okay, an architect will be thinking about the site characteristics, and he will design a form according to the orientation of the site, and he will design openings, maybe thinking about the aesthetic aspect, but also thinking about what is the daylight that can deliver to our environment, or what is the air change that can happen through one single window or a single door. And after addressing the passive strategies, and as you are designing an opening, you are rendering the light to come in. So along with that, you'll get a lot of heat. So how to shade that heat? So the cost will be in a sequence. So an architect solving all these sequence, and then the effort of the engineer comes in. So a mechanical engineer will be involved along with the, thinking about the strategies to resolve the heat load. Maybe. As we said, we are consuming a lot of resources for the construction, and energy will be a resource which is used at the time of operation as well. So the lighting, plug load, electricity, fans, whatever involved with the building will be consuming tremendous amount of energy. So these things are interlinked, because we know that if we are designing a poor envelope or a poor building shading and all, so we can understand that amount of incident solar radiation, which is heating up the entire environment, will be different. So the mechanical engineer has to size up, and the energy consumption will be consecutively increased. And so this is how it end up. We have to take decisions at each of the steps to achieve energy efficiency. And so with the help of the software tools, we can understand this kind of, what is the consumption that generally for particularly for a building. So let's know the procedure. We were discussing we'll be doing EQuest software simulation tool because it's a freeware available across the globe presently, and it is developed by Department of Energy, US. And it's kind of an advanced system using DOE tool, DOE language. So you can install the software within your system without any, purchase or payment. And once after installing the software, we have to create the geometry. So this is the procedure, okay, the core procedure that we generally do. If it's a multi-story building, you have to think about how do we do the zoning for each, building block, and what shall be the self-shading and mutual shading aspect. And if it's a single story building, you have to again think about different blocks. So this is how you have to, according to the scale of the building, you have to model the geometry in your system. And the second thing will be the inputs. The inputs in the sense, we said the building constitutes a lot of components. So based on that, there are different inputs. So we'll be working on these inputs throughout the session. And finally, after giving all these inputs, we should know how do we generate the output, right output. And there are endless scope, not just energy simulation and getting the result. You can do parametric analysis to understand, different the various systems within one single building itself, or you can, alter the component and try in the future. And you can create advanced HVAC systems as well in the, software. And we can do lighting simulations, but not in EQuest. Using other softwares, you can do lighting, daylighting, or artificial lighting. And also rating system compliances. Rating systems we were talking about, like the USGBC lead or GRIHA or IGBC. Based on that, actually lead is associated with many global simulation engines, and also CASB or any other STDAMA. So you can work out based on that. So we may not be discussing these aspects in today's presentation, but we will reach you till there. Like how do we do the, how is the workflow that we are going to reach the kick point. And so let's come to the building analysis procedure. So before that, is there any questions? Let me.
To all the participants, you may interact with the speaker, with Ashika ma'am, at any point of time, since this is a simulation workshop. So if you have any doubts, you may unmute yourself and ask any doubts. Yeah, just one at a time, so that we don't have too much disturbances in between. Ashika, if you're speaking, I think you're on mute. So please unmute yourself. Yeah.
I think I'm audible now.
Yes, yes,
So
you are.
yeah. So while we speak about building energy analysis, there are two methods generally follows. So one is the prescriptive method. Okay, prescriptive method is something as the name indicate. You will be doing a lot of manual work and you will be making a lot of prescriptions to prove that your building energy consumption is less. So in this case, you may have to put a lot of manpower, I mean manual time and calculations and effort upon it. But the second method is the simulation method. In the simulation method, if you know the science behind it, definitely you will be able to do this exercise in much less time, and as well you maybe having the flexibility, because you know if in prescriptive method, let's say you are going to optimize something like such a you are going to reduce the energy load of your I mean heating load of your cooling load of your building. So in that case you may be having you have to give the section of the wall, you have to give what material are you using and what is the plastering given, what is the paint given, and what is the reflectivity, U value, conductivity, all these things associated with this material. You have to collect the product data sheet and then you have to do manual calculations. After finding out the resistance value and this reflectance value from the product data sheet, you have to manually calculate and prove, okay, this will be the energy, effect, net effect, and it is coming under this the required value as per the energy conservation building code. And in the simulation method, if we give the input, you will directly get the EP output. And the major difference is that when it comes to the cost factors, and then actually I'm getting confused. How can I explain to you this in minimum sentences? Because this is a whole lot of process we used to have. In this compliance methods itself, we used to have elaborate sessions. So let me tell you the logic behind it. As I said, prescriptive method, you have to prove everything by prescriptions, and simulation method, you are going to do the simulation. And the benefit of this is that when you do prescription, you have to cross check almost every values given in the code, and there is no this what do you say for that, the net effect won't matter. But in the simulation, the net effect matters than what is each of these prescriptive steps happens. And I'll do one thing. I'll take the code and show you, then you'll get a better idea. And in the code, there are some mandatory requirements that you have to follow anyway for both of this approach, both prescriptive and simulation approach. And for the prescriptive, there are another, other tasks that you have to follow. And in the simulation, we can have some shortcuts that we are going to learn today. What are the shortcuts that we generally do for? So let's come to energy modeling. And the energy modeling process is a linear one that we follow. The first step is we have to collect the raw data. Like what shall be the data when you talk about building? Okay, the building is made up of walls. So you have walls and there will be systems, as we said. And in detail, we'll give you a checklist. So you'll get what are the parameters within that. So based on that, you have to understand what all data are needed for simulation. So you should know how to process it and how to make it to a format that you have to give unto the software. And after data collection and data processing, we should know how to formulate the model. And after modeling, there will be some kind of errors or some kind of common mistakes associated with it. Then we have to solve all these kind of discrepancies in your model compared to the actual system, and we can create the result or the output of the model. And we can analyze and find out the P ratio or whatever is practically used. So this is the general process. In this step, if you are working out on a software, step 1 is the raw data and processing of data. So the raw data collection is you have to collect it from the consultants like architects, MEP consultants, or PMC, or the client itself will be having set of things that they can provide to you. And formulation of model and solving the model, processing the data. So those 3 things will be done by a consultant, green building or energy analyst consultant. And step 3 is also done by a consultant, and final result will again be given to the architect or client or the authority that is asking for. And in the building simulation session, let's see. So the first thing that we start will be the building design parameters. How the spaces are designed, how the envelope is designed, how the shading device is designed. Based on that, we will create our model, and also the outdoor environment factors. What are they? The climate, and the surrounding that where our building is located, and the geography of that particular point. If you are building on Trivandrum, what is the latitude and longitude. So based on that, the sun angle changes and the climate changes. So those kind of information, that is the macroscopic information, and also the microscopic information, like is there a water body nearby or a surrounding building which is casting shadow on your building. All those kind of information should be found out. And then we'll make the model systems, and we'll come to the outputs. Output can be either indoor environmental conditions like the thermal comfort aspect, or the visual comfort aspects, or the consumption aspect like the energy performance. And generally the data required for this energy simulation shall be, as I said, we are going to collect from the consultants the floor plans, okay, the sections, elevations, everything shall be in the AutoCAD, because we have to reshape it for using it in eQuest. And the lighting design, fixture details, if there are any cut sheets or controls, sensor details, and what is associated with HVAC, what is the system, what kind of ducting, and what about the outdoor unit, indoor unit. So all those information should be there. And when we think about the walls, material assembly, like for the walls, roof, windows, wall, floors, what are the materials and what are the specifications. And if installed, what is the renewable energy system capacity? And most importantly, the operation schedule of the building. Okay, we know that suppose you're going to take a office building, we know that it's a daytime occupancy building. Similarly, if you go for residential or hotel buildings, and we can say it's a 24-hour occupancy building. So based on that, the number of people who are entering the building changes according to the time of the day. So we have to know that information as well. And when it, site information, like what is the stretch of the land, and if it's an infill development or is it a urban development waste. And if possible, 3D views available, because based on that we can make a model which is looking close to the architectural model. And these are the complaints document that is available. This is the base of HVAC, ECBC. And in the code, if you go to the section, I show you. So I shared this energy conservation building code with you. This is the basic document as I discussed earlier. This is Energy Conservation Building Code 2017. It's having an early version, but there is a published version available online. You can get it from the website. And see, when you come to the end of this document, there will be compliance forms. And these compliance forms are categorized like the whole energy conservation building is categorized into 5 sections. Building envelope, lighting systems, HVAC and controls, electrical systems, and renewable energy. So under these 5 sections, they have already given this kind of checklist. So you just want to read and prove your building is following or not. So this is how earlier I said I'll show you what are we going to do for the prescriptive thing. So I'll simply take the envelope checklist and will explain. So here, as I said, these are the mandatory provisions that we want to follow. So just you have to follow that anyway if you're going to construct a commercial building in India since 2017. And in Kerala, our building code is notified in last November 2020. Yes, November 2020. And in the prescriptive compliance option, so you have to again prove implemented factor, this factor. When you get time, you can go through that, and we may be taking it afterwards, like after the session. So let's come to the core aspects. Core of energy modeling aspect. Okay. So when we do energy modeling, or when we do this kind of simulations, how do we prove that our building is efficient? Because we need to compare it with some standard case or some fixed case. So for that, generally we use Energy Conservation Building Code ECBC standard case, and which is based on all particular values has been taken for ECBC, as I said, for the 5 sections. And for the proposed building, we'll generally make according to our design as design case. But that should also be performing better. It should not be the underperformance case. You should have that logic behind while designing, and to make your proposed case better than the standard case. So then we can say our building will be able to save this much amount of energy compared to the standard case. And so let's discuss about. Do you have any doubts in that standard case and proposed case? Because we will be using it throughout the session.
I will again kindly request all the participants, when Ashika has asked something, kindly unmute yourself and reply, or you can drop a message in the chat box so that we understand that you are following us. So yeah, please cooperate. Yeah, Ashika, I think Vishal Chetri sir has asked to explain those terms again.
So we were discussing standard case and proposed case, right? Standard cases, as the name indicates, I was discussing about Energy Conservation Building Code, right? Because Energy Conservation Building Code is the base in India that we follow as the standard case. So all the building systems, the envelope systems, HVAC systems, lighting systems, renewable energy, whatever we are going to implement, execute building, should be based on these standard values. So if you made in accordance with the ECBC, it will be the standard case. And proposed case is nothing but the case that the architect is going to design. And as we say, proposed design in the case of architecture, it is similar. Similar means what are we going to propose? So in this, the HVAC systems will be proposed by the HVAC consultant, electrical system will be proposed by the electrical consultant, and design will be proposed by the architect. And what our intention is, our proposed case should be better than the standard case. We have to design it in a way that our proposed case should perform and should give some savings compared to the standard case. And sometimes you must have heard for the term like, as designed case or, actual case and all. So, those kind of terms comes when the architect design a case which is not up to the standard case. And because the performance will not be, on a recommended level. So then at that case, in that kind of scenario, we will keep it as an, we will term it as actual case or as design case, and we will propose a better proposed case. So the proposed case should be better performing than the standard case. That is the, logic behind it. That should be the logic behind it. Because we are going to design an energy efficient building. And for that, the proposed case should be better than the standard case. And if you are not able to design something, better, you may keep it as an actual case or, as design case or something. Okay, thank you. So to the next slide. So here comes, we are going to start. How do we do the simulation? So when we start the simulation program, okay, there are certain things that we are not supposed to change at all. We have to keep it as constant for both these cases, for standard case and proposed case. Because as I said, you to make it, to show that your building is efficient, you have to compare with the case. So for comparing, you may have to model two buildings. So the first one, if you are going to design in an EQuest, the second building should also be in the same simulation program, EQuest. Or there are a couple of available simulation programs, like you can go for IESV or Design Builder, or any available programs. But if you are choosing it, whatever program that you are choosing for the standard case, you have to use it for the proposed case as well. Second constant thing is the weather data. Why do we keep weather data constant? Because we are going to build on the same land. Okay, we are saying, okay, our building will be on Thiruvananthapuram. Or if we are saying our proposed case in Thiruvananthapuram, then we have to simulate the standard case also for the location. Same with the same weather data. And what is the third constant? Okay, it will be the operation schedule. We were discussing, okay, we may be having a daytime occupancy building or a 24-hour occupancy building. So in that case, we have to clearly state, like, what is the operation timing hour based. So, and you should have to keep it as constant for both standard and proposed case. For example, if we are designing a school building, okay, so the school building will be working 9 to 4. And for the standard case, it should be 9 to 4, and the proposed case also it should be 9 to 4. It's logical, nothing complicated in that. Another thing is the thermostat points. Okay, thermostat set point is the AC set point temperature that we keep. If we are keeping 24 degrees Celsius in the standard case room, you have to consider the same in the proposed as well. You won't be able to, increase the temperature and then say, okay, my energy performance is better. I'm getting less energy consumption. That's not logical. Similarly, for the equipments and other things, those kind of things should be constant. And the occupant load, okay, the number of people that you are going to design the building, it is anyway, according to the area, you may be having some kind of local bylaws, and otherwise the standards, architectural standards will be there. So for how many people you are going to design this particular space. So in the simulation program as well, we have to change it as, make it as constant. And what can be the variables that we can try? And as I said in the beginning, what can be the energy conservation measures that we can apply? So the first one will be the morphological characters. That we said the shading device that we design. Okay, in the standard case, you can simulate without any shading device. But for the proposed case, according to the architect designs, or if you find that the architect shading device is not up to the mark, you can redesign it like architect can go for a second option or a third option. And finally, we can optimize. Or a green roof. Or, if you come to the material properties, when it is a material properties, the U value, R value as a GC. So when we discuss the material parameter, building envelope parameters, we will discuss this in detail. And system side, COP, ER and all. So according to those are the technical things, technical specifications that we can change to improve the performance of our building. I got a question. Let's see. From which source the weather is collected? I'm going to show that. And can we import 3D or 2D proposed design in the software? We can import. I'll show you that how. But there are little things has to be done. If there is a change in constants due to some external reason during the lifespan of the building, how it will be addressed or considered? Okay. In future, then you may have to do both the cases for that. What is the scenario that is changed? COP and ER I am going to explain. Okay, in the HVAC system under the systems. And let me tell you, if these kind of constants, why are we saying that these things has to be kept constant? Because it's for this particular energy simulation process. Okay, because our building hasn't been constructed yet. So we are forecasting for a scenario that is, that we consider as a normal, as a what do you say, ideal condition. So, if you say that your external conditions are different due to lifespan of the building, then after particular year of operation, you may have to do some kind of, analysis in form of an energy audit. And then you have to simulate your building. You have to simulate your building upon the mapped conditions that you have documented based on your documentation. And then again, we can forecast and we can come up with a solution. Otherwise, before the building is constructed, it's it's kind of unforeseen. You might not be able to know how to execute those kind of features. So all these are relative. Please keep that in mind. Okay. And COP is coefficient of performance and EER is energy efficiency ratio. We will explain. Okay. So let's go to that point. Okay. So when you make the building model in HVAC, earlier we said there is a 3-stage process. One is we are going to build the geometry, we are going to give the input, and we are going to generate the output. So for those 3, considering the design model credits, what all things we have to be conscious about? One is the opening. We have to design the opening as per design by the architect. Because what is suppose your wall window ratio of facade will be some 20%, then you have to keep that wall window ratio similar in your EQUEST model as well, your simulation model as well. Or the opaque and envelope types that you say, opaque in the sense the wall or whatever is, would not permit the light. It means opaque, we know that. So the wall, the doors, the roof, they are generally termed as opaque components. And interior lighting, power and controls. That also you have model as electrical person design. So we already explained this credit. And this is for the proposed case. And when it comes to the standard case, everything should be according to the ECBC code. If your HVAC consultant designs some system, you should not look into that for the while doing the standard case. You have to follow the code. You have to go to the HVAC session and you have to model according to that. Okay, and if in generally I'm quoting Kerala because presently seeing those kind of examples over here. Everywhere it happens because till now in the industry we generally start with architectural drawings and then the client go for building permits and then the client may be starting the construction, and after starting the construction, he will be appointing other consultant, like MEP consultant, renewable energy consultant, on a later stage. So in that case, you may not be having those kind of data in the beginning itself. So what do? You may have to minimally comply with the code then. Because if you don't have an HVI, you don't need to rush and appoint an HVI consultant in the beginning. Rather than that, you can follow what is mentioned in the code. So here we were discussing. Yes.
Yeah, sorry for interrupting. There are a few questions in the chat box.
Yes, I'm addressing to that. I think so far I have answered all questions, and there is a new question. Will the software consider buildings which are based on vernacular architecture? Yes, you can. You can work out on vernacular buildings, but this. How does the software? Work out is based on the inputs that we give. Vernacular building in the sense the materials and the design features will be different. So we are going to model that. So the software itself won't be designing anything or predicting anything. Whatever information we give as an input, based on that, it will generate an output. So we can definitely work out. And here we were saying what are the components that under design factors, the walls, roof, okay, and system side can be what do you say, the fixtures or the BMS systems or water systems, whatever it is. So I am sure, I am thinking that all of you are, presently, all of you know that how do we design the form or design the building in the EQuest. Is it? No, there are a few more facts. We'll come to that. But this is the basic information that we have to keep in our mind. For standard case, how do we model? For proposed day, how do we model the building design? So let's come to the second aspect, that is the space use classification. So sometimes your building will be of single use, and sometimes it can be of mixed use. So in the case of building a single use, it's easy, because according to these are the categories that is given under energy conservation building code. So if you are going for a commercial development building, but in ECBC they are stating commercial with a broad range of broad category of examples, because it may not be exactly similar to the commercial definition of commercial in your local law. In Kerala, commercial and mercantile buildings, classification is kind of narrow, but the assembly buildings, educational buildings, other business buildings, everything will be coming under hospital buildings. Everything will be coming under ECBC commercial. So you have to cross check it. Okay. So according to this ECBC space use classification, you have to take the values. If you go to the session that is quoted, like session 2. One second. Sorry. Yes. According to the section 2.5 of the code, the document I shared in the drive, you can take the classification that you can fix that. And third factor is the schedule. Schedule we discuss. What are the operation timing of the building? Okay. So it will be based on the hourly variations, like as discussed. Our building may be operating according to that. Suppose in the morning there will be 3 people will be there at 7 o'clock, and by some 8 o'clock there will be 4 people, and by 10 o'clock most of the people will be there, and again by some 4 o'clock some people will leave and will be there, and again by 5 o'clock more people are using it. So based on this, you have to map how will be the occupancy pattern in your throughout your building. So here you can see a example of an office building schedule. Just see, starting from 9 o'clock, 7 o'clock the building it occupies, but the peak happens by 9 o'clock, and the peak ends at 5 o'clock, and again some kind of offset will be there. So you may be having this information after discussing with the project plant manager or architect even knows the information. Otherwise, if this information is not given by your building team, you may have to use the standards as per energy conservation building code. Again, in energy conservation, I will show you the code. See, these schedules are given under section 9.13 is school building. For different buildings, they have given how shall be the operational pattern, operational timing of the school building, educational building. Okay, so based on that, you may be able to. Yes. And another important factor is that there are two kinds of schedule and equals that at the time of modeling I will show you. One is a fraction schedule. In fraction schedule, as you have seen over here, we are going to express in terms of fractions. For example, the occupancy. Okay, we are saying, okay, 10% of people are there and 50% and then 95%. And maybe lighting will also be in a similar manner. Like we are going to switch on some 20% of light in the beginning, and as all, the entire building gets occupied, you may be switching on all lights to the 90% or 100%. But in case of HVAC, okay, HVAC or any other, ventilation aspects and all, we generally speak in terms of on-off schedules. So that on-off schedule in the sense, those kind of schedules will only be having 0 and 1 as values. 0 means off and 1 means on. So at the time of creating the schedule, you will get a clear idea. Another schedule is there, temperature schedule. As we said, for HVAC system, we have to keep some kind of set point, right? In our room, we have the remote, so we will be controlling it. So similar to that, we have to set a remote for all the rooms in EQuest. So in the remote, you have to give a schedule which has a temperature input. So let's go to the second step. Second step is the building envelope. Okay, when you design the building envelope in EQuest, can you see that red line which is drawn? If you look into it, you can see that there is an attic space or a balcony space is omitted from it. So why are we doing it? Because we generally considered the closed thermodynamic zones for our EQuest analysis calculations. We don't need to do any semi-open spaces or any ventilated, attics or all those kind of redundant spaces. So here, if you see other zones like 1%, and according to the area and enclosure, there are 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 zones. Okay, I think you got some concept about this. Go back. Let's go to the next slide. Another factor. Okay, so first one is we were talking about the space. Second one, when we think about the envelope, material factor. Suppose your building has your we will talk about the opaque assembly. Okay, so this is the wall periphery of your building, you can see, right? So all over the surface we are using brick. It can be any type of AAC brick or normal brick or anything, but for this particular project, suppose we are using I'm not able to change my slides. Yes, in this building, they have used both clay brick and AAC block. So we have to understand where are we used clay bricks and AAC blocks. So we can say the major construction was happened using AAC blocks. But in the near the toilets or duct spaces and all, for, we know what is about practical purpose for why we are using it. Must be using some kind of clay brick. So if you calculate the percentage of area of this clay brick is less than 5, then you don't need to consider the particular material. You can take the entire material as ASC block. So this is another parameter that you have to keep in mind. And the third thing is, if your building is having some kind of, slanting surfaces, like, tilted surfaces, which is less than, 45 degree, then you have to bring it to 45 degree. It is like, I'll tell you, if 0 to 45 will be, if it's near 0, it's 0. It's near 45, it's 45. And 45 to 90 will again be like that. So this is how we have to offset and take to the near 45 degree value. And if there is any manually operated fenestrations, we don't need to consider that, because we cannot predict how, manuals will be, how human, occupants will be switching on and switching off the lights, or switching on the fans, or removing the curtains and all. So those kind of aspects won't be considered. So maybe if it's a fixed shading device or something, we can model. Otherwise, we don't need to. Suppose you can see this building, right? This is designed by A.B. Lal, Ashok B. Lal. So in this, he has given some kind of static shading device and also some kind of movable devices. This has to be done as a subjective analysis. You won't be able to keep it into this. And these are another, I'm just showing you some examples. How do we take this while simulating? Okay. Here, here is a huge 2-story height, this thing, what do you say, atrium space. And it is semi-open. So you can take it as a single thing, which is not a thermal zone. You can consider it as a local shade, not of considering it as a thermal zone. And here are shading devices which are overlooking to different directions. So you may have to manually design the shading device. And for this, the effective shading area has to be considered, because for all those things, we may not be able to keep the particular angles, as I said. And suppose here is an example you can see. So this is an energy simulation model, and this is the architectural model being made. So in the architectural model, you can see there is a cornice which is projecting maybe some 1 meter or some 50 centimeters, but that's not considered in our energy model. And in this, on the top of that particular building block, there is a slanting edge that also has been taken as straight, because in energy simulation we generally consider the thermodynamic heat transfer principles. So how does the heat transfer happens, and what about the volume, total volume of that particular building? And we are free to simplify the architectural model based on that. It is allowed. It is allowed by principle in energy simulation. Okay. And when it comes to the lighting, for lighting, the proposed design, we know we'll get it from the MEP consultant, electrical consultant. And for the standard case, it should be in accordance with the ECBC. And in ECBC, there are 2 methods for taking this lighting power density. One is the space function method, and one is the building area method. So this, as name indicate, building area method means for the entire total building area according to the type of the building. In ECBC, there are certain values given. I'll show you. Yes, here it is. Okay, so based on these values, you can take whether it's for building area method or it's for space function method. Okay, you can see that ECBC that I shared in Drive, page number 62. So this one is based on building area method, and in that, according to the type of your building, they have given one single value for your, for calculating the light power density. And when it comes to the space function method, that means in your particular building, there can be different spaces. So you have to calculate for different spaces and we have to take the cumulative. See, I'll show you a table. Here, for this is a ground floor plan, what's there in my screen. So here you can see different spaces, right? Based on these zones, we are calculating what is the area of that particular space and what is the number of fixture and what is the wattage of that fixture. And finally, we can find out what is the light power density of that particular fixture. Okay, so, and so lighting is another section, and finally HVAC. Last section will be the HVAC section. So before going to this section, let me take the chat. Please share attendance link. Is there any questions till this point? We discussed about building envelope parameters and we discussed about lighting, HVAC. Yes. Okay. So let's proceed with the HVAC. So in HVAC zones itself, we have to go in a similar approach, like, while creating the HVAC zone, there are certain things to be followed, but for the specifications, as we mentioned, for standard case, we have to take the spec from the ECBC and proposed case from the consultant. Okay, so let's simply show that. How do we design the zones? Okay, suppose you are building as a 12-story building, which is having a rectangular plan. So how do we generally zone it? There can be a perimeter zone and there can be a core zone. So this is the general idea that we zone on a primary basis. In ECOST, if you look into that, you will see zones named core and perimeter. So that's how ECOST understand. Even if it's not a perimeter core planning as such defined in architecture, we have to design the thermal zones according to that. Okay, why do we do that? Because we know the perimeter zone will be exposed to the external environment. Okay, you can see in this slide, on this slide. So it is directly exposed to the sun, wind, and rains. And the innermost cones won't be having that kind of interventions. It will be just directly linked to the floors above and floors below. So in this case, you have to the thermal heat transfer which is happening on this floor, which is having a window, will be different from which is not having a window. This is the reason we generally take it into two single zones. And there are a few more, credits. Like when you take the perimeter and core zones for working out for energy modeling, you have to restrict it for 5 meters. Can I? So suppose this is your building, right? So when you have this as a core, when you take this as a core, this distance should be less than 5 meters. This distance. Okay. If it's not 5 meters, then you have to divide in a different manner. Like your core is there. Suppose this is the 5 meter, this is 5 meter. Then you have to divide like this. If you are doing a perimeter core zoning. Okay, so this can be 5 meters. Okay, and the rest of the things you can take it as a different zone. This thing. And core zone can be different. So you will have a core zone, an intermediate zone, and a periphery zone. So this is one way of doing it. That is a perimeter core zoning. And I think you are clear why are we doing it, because considering the heat transfer to that can happen with the external environment. And let's see. And there are some, you are not supposed to club these kind of perimeters and core zones together. That's the rule 1. And rule 2 will be space usage. So this is based on the, space dimension. The first principle is based on the space dimensions and the heat exchange considering the external environment. And the second principle will be based on the usage of space. If you are building as used as classroom, or this building is a computer lab, the space is a computer lab, then you may not be able to club these two zones together. You have to keep it as separate zones. And when we okay, and let's come to the second type of zoning pattern that I can show you. So this is the one I was drawing and showing you. The zoning according to story can be like a core zone will be there, where we generally give the staircases, and in the periphery we'll have different spaces. And according to the space, again we can say, okay, these can be the corridor, and these two spaces will be different kind of offices will be there, or different kind of classrooms, or whatever, cabins or open office. So based on that, we will do zoning in architectural terms. Let's come to another aspect that I discussed before, the orientation aspect. So in the same zone, same plan, we can do actually this, as we said, this is according to the spaces, like this is an open office or this is a closed office, like that we can say. We'll come to the third pattern. So in this, what you can say, this is like, according to the orientation as well, you have further divided that space. Okay, let's see that this was a single volume in the earlier space zone, space use wise category. But when you added that orientation input, you have to further divide it into two pieces. And the final one is the zoning according to the partitions. Let's see that partitions. According to the partitions, that those zones will again get divided into 4. Okay. But generally, in our ECOST modeling or energy modeling, we need a zoning based on thermal mass. Okay, though we know that how does this heat transfer happens on a space. Actually, here are a lot of basics that we skipped. So I'm not sure whether the thing has rightly conveyed or not. Let me just tell you. How does heat transfer happen on a building? We know about conduction, convection, radiation, and all those. How does heat, transfers by these principles? So considering that, we are defining the zones. Okay, so as I said, building that is exposed to this external environment will have more conduction heat transfer through walls, conduction through walls. And also conduction heat transfer happens through roof, and it can happen through the floors as well. If there are some, highly, unconditioned space or something on the, underneath floor. But in the core zones, heat transfer will be happening between these spaces and also between the floors and slabs. So this is how we finally arrive at the right zoning pattern that we have to do for a space. I'll give you a question, then you will get an answer. So please tell me, based on the principles I was saying, okay, the thermodynamic principles and the user pattern that we use, and also the windows that we were discussing, what shall be the right way of zoning if we consider equest, A or B? Please look into it and type on the chat box. Can you please? Oh, sorry, I missed it. I'll keep. 11:37. Please explain again. I think you want me to explain the zoning again. Okay, I'll do that. I'll do that, and I'll keep it in full screen mode, and I'll do that. Yes. Okay. We were discussing in terms of how do we zone a building, because architectural zoning and our P1 and P2 perimeter 1 and 2, because I kept it for the east and west, let it be P, as the radiation will be somewhat same, and north and south is also somewhat same, right? So that's why I kept it like that. Perimeter, it just means perimeter. Yes, it is. And suppose I'll explain from the start, because this is the key principle the way we going to start the zoning for the modeling. We are going to do it in AutoCAD, then you will get a better idea. So first of all, we have to look into the use of the space. What is the use of the space? According to that, we can give the different zoning pattern, because according to the use, we know that heat transfer changes, right? As we said, apart from the conduction, convection, and this radiation from the external environment, people also adds heat to the building. So the occupancy matters a lot. Okay, we know the way we sit on a computer lab will be different from we sit on a design studio. So according to that, we can divide. That is one way. And the second consideration that we have to look should be according to the outdoor environment. Okay, is there an exterior wall or a window, or what is the orientation towards of that window? And based on that, we have to divide the zone. And if there are unconditioned spaces like toilets, I didn't mention this before, like toilets or unconditioned corridors or parking spaces, so all those things can be clubbed together. And the second thing will be, when you think about the conditioned space, you have to think about the area, you have to think about the occupancy, then you have to think about the orientation, and you have to think about the exposure, and then we can club the homes together. And generally, this balconies or open kind of thing. In the do you remember the picture that I showed for the envelope? So in that we have eliminated that balcony and that the unoccupied space. Not unoccupied. It will be occupable spaces, but it's not a part of enclosure, building enclosure. So we can omit those kind of spaces, and instead, if the balcony has an effect, has casting some kind of shade to the opening on the below floor, then we can design it as a shading device. So let's, this is the principle that we were saying, heat gain and heat loss principle. And then I was showing some kind of, it's like a series. I was showing how do we do the zoning. So in the first image, I was discussing zoning into story, we can say. That is the first thing we can, differentiate, right? The ground floor heat transfer will be different from the intermediate floor, and intermediate heat transfer will be different from the top floor. Can anyone explain how is it getting differentiated? Just because we know the walls will be carrying same kind of heat transfer from the sun, and when we think about the floor, ground floor, the floor is attached to the earth surface. But if we consider the first floor, the floor is attached to the ground floor. So is the heat transfer same for when you are attached to the earth and when you are attached to another conditioned floor? It will be different. So that's why we are doing the zoning according to the stories first. And what happens when it comes to the top story? The top story will be like, it has more exposure because our ceiling, our roof slab is exposed to sun again. So I'll do one thing. I'll sketch and show you once more, then you'll get a better idea. Suppose this is your building. See, this is your building and it has some 3 floors. It has 1, 2, 3, 4, 5 floors. Okay, here we know, okay, if this is east, you will get direct exposure towards this wall in an equal amount for all the floors. Here as well, it is directly exposed to sun on a similar manner. But consider the roof. Okay, you will get direct exposure only on the 5th floor. You won't get that kind of exposure for the ceiling of the 4th floor, 3rd floor, 2nd floor, or ground floor. So that's why we have to split on, as I said, zoning according to story. We have to start with that. So if we do zoning according to story for this particular building, how does it become? Just see, imagine either you can do ground floor as a, ground floor is having exposure to the ground again. So heat transfer for ground floor will be different. So, ground floor will be the first thermal zone that we can give. And the second one will be the first floor and second floor, third floor. Finally, 5th floor will be having a different heat transfer equation. So here we can see these floors, these intermediate floors are having similar kind of exposure, right? In terms of, exposure towards wall, and if you consider floor as well and ceiling as well. So we can club these 3 things together, or we can keep a multiplier in the software because heat transfer will be same. So, and the second thing you have to consider is the space of each floor. If suppose if you are having typical plan for all these floors, then we can club that together in the simulation model. Otherwise, you have to model it in as a separate floor, separate entity. So here I was discussing in terms of spaces. On floors, how do we divide? First one is the use, space use you can take. And let's come to the second. Let's come to the second item. That is the orientation. Okay. Here we know the space. Just see. Suppose north is up. Okay. So here this particular facade is exposed to north. This one is exposed to south. This one is exposed to east. So the solar radiation which is hitting each of these facades will be different. So we have to do some kind of zoning in between to differentiate that. So this is how it works. Zoning with respect to orientation. Here east and west differentiated. North is same. In this as well north is same. This one as well north is same. And again, according to the partition itself, partition and orientation again we zone. Just see here again. Within the space again we are differentiating. So, and is there any questions now? Okay, so let's answer this particular slide. And then you will be having a better idea, like, I can at least make sure that you are clear to this concept. Option A or option B is the right way of zoning in a zoning for energy modeling. there is a, this is an office building and there are many cabins, and you can find the staircase. Actually, I have done zoning for only for the top portion. You can see. We can do the rest of the floors as an exercise later, but just look at the top portion of this, like whatever is there within this color map. Please look at that and say which option is right. This one is right, or this one is right. A or B. Please type on the chat box. I thought of a poll, but poll is not, working well. Let me try once more. Now poll is still inactive. Yes, poll is working. Poll. No. It's asking for question. Okay, please type A. Yes, all of you are saying A, B. Yes, okay. Okay, is there A, B? Yes. Yes. Okay, so many A's and some B's. Okay, so let me explain this. Here you can see what are the four things we have to consider. One will be the orientation. Second one will be the opening, and third one will be the occupancy, and fourth one will be the floor or use of the building. So considering all these factors, let's see how A is getting zoned. We have designed, okay, this is a space, this is a single zone, and corridor has given 1, 2, 3 zones. To the office space in the corner, you can see again it's office space, and and for this as well, please consider north as up. Then you can see the northern zones and how the corridor was different. Okay, and let's see the chat box again. And let me give you a hint. Give you a hint once more, and then please tell me A or B. Okay. Here, why should I say? Okay, I'm saying north is up, right? Not able to keep consistency with this mouse pointer. Okay, so north is up. Let's see. So this will be west. So we have, if you consider this zone, okay, right, exposure, right exposure, right exposure, right exposure, right. Is it right exposure? Because see, we have taken the entire thing on a single manner. So here should be some other zone, right? For this particle, because it is having exposure towards north as well as towards east. Okay, so this one is not right. Like if you look into the second option, we can see, okay, that is taken in a right manner. And if you look again, see this corridor is having exposure towards west as well as towards north. Yeah, both these sections. So here we have taken, say, on a different manner, like this. Okay. So now are you clear about it? B is our answer. So let me ask you, like those who answered A, how do you come up with it? Like you missed this one single point, or did you find any other logic other than what I explained? Yes, fine, fine. Okay. So first of all, look at, we have to look at, as I said, we shortlisted, right? That orientation part, the usage part, and the window part, and the, what I missed, floor wise. Okay. So let's go back. Let's go back. Let's go forward. Or is there any more queries? We'll cover that and we are going to the next session now. I wanted to finish all these logics today and I wanted to start with the, modeling part as well. I answered it because the center corridor is exposed on the west and east, but green corridor exposed is different compared to the yellow one. Okay, fine, fine. Okay, that's that way you consider, but you know, in this case, this yellow has also to be in a different, should have been in a different color. I actually zoned it different, but you know, the opacity when I reduced, I think there is some issue happened. Okay. I think because it was a different tone, even though all of them were in a yellow color, that particular one was on a different thing. So I think now please look into it. I think the problem must have been solved, right? Because even if you consider the corridor, you did not consider the space, which is having this office on the east end. Okay, let's move. So apart from these electrical and HVAC loads, there will be some kind of miscellaneous loads in the our building. It can be some kind of exhaust fans or exterior lighting, or elevators will be there. And if there is a swimming pool or something, the equipments associated with that will be there. And if there is a pantry or kitchen nearby, which is not primarily for the building use, but as a supporting facility in an office, if there is a kitchen, it can be added to the miscellaneous load. So those kind of aspects shall be calculated, and it has to be calculated manually. We can calculate, or else we can add different type of miscellaneous loads within the building simulation engine. And when we come to the last part, okay, the simulation tools are not so perfect. Okay, there are some kind of limitations. So to overcome the limitation, we generally strictly follow the thermodynamic principles. And whenever there is, some kind of factors which are not so close to the practical conditions, we have to take certain assumptions. And there will be some kind of trade-offs that has to be happened. Like suppose if we are designing some building which is having some kind of slant, like suppose. Okay. Suppose you are going to design a 30-story building. Okay, this is not a small building; it's a 30-story building. So in this 30-story building, here will be the slanting like this, and it may not be. We may not be able to model exactly similar to the building geometry in the equist. So in that, what do we generally do? We will divide the floors in one by one, and we will calculate what shall be the volume of one particular floor. And based on that, we will do the thermal zoning. Like then finally the building will be on a step pattern like. So if your real model is on a slanting one, but your equus model can be of a stepped pattern. These steps are not clear, but these are steps, okay. So that is one, I mean, that's how we generally take assumptions. The volume of the building, the entire portion should be same, but the form can have a little, difference compared to the actual case. If the whole thermodynamic heat transfer you can maintain within the system, it's fine. And when you use the HVAC systems in accordance with the ECBC sections, and if it is not according to that, you can strictly follow that for finding out that. So ideally, the proposed and standard case design, whatever assumptions you are taking, should be same. It should not be different. So here I can show you some of the building simulation models of some of the famous buildings that already what do you say, recognized by people nowadays. So the first one is the National Bank of Kuwait. For that, this is the simulation model made this particular lighting and for the energy purposes. And if you see the exact form, the form is not exactly same as what is there in the actual case, but the inspirations will be made and the assumptions has been taken to get the effect of that particular system design. And this is, you all of us know this building. Okay, this is Gherkin, and see, this is also considering the wind pattern and the flow that it can make and how it is getting distributed and all. So they have altered. In the first image, you can see the wind flow is not so perfect. So they have altered that building according to that angles, and they optimized using this simulation tool after formulating it. So let me sum up this procedure. So first one is the energy modeling software. We have to select one particular energy modeling software, and we have to give the description of the inputs, and we have to give the energy savings. We have to find out the energy saving. Energy saving will be the output of our system. And if our proposed building is not performing well and it is not having any energy savings, then what shall we do? We have to come up with certain recommendations. So based on this, we will be preparing an energy conservation building code compliance report or an energy simulation report with suggestions. Okay. So these are the sections of the report. First one will be the simulation input. Under the simulation input section, we have to give envelope input section, HVAC input section, and lighting input section. In the output section, we have to give as designed case. That means I consider case because on a general case, people may not be much conscious about the energy conservation aspects. So our proposed case won't be as efficient as the standard case. So in that case, with the suggestions, you have to give another proposed case. Okay, considering these three outputs, we have to do an API ratio analysis and energy efficiency interventions proposals. Okay. So let's, I'll simply show you API ratio analysis. What is API? Okay. So tomorrow we will be taking one by, whenever we take one section, we will go through all inputs, and we'll, at the same time, we will learn how to convert it and how to import it within this system, software system. Okay. So first one will be the envelope section. So let me ask any more if there are some doubts. We'll go for this break for. Okay, sure. Yeah, it's 12 o'clock. So we can take a break for 10 minutes or 15 minutes. How much is the break? how do you generally proceed? I was also wondering after watching the time. It's from starting from 10 to 2. So let's see. So we'll take a break for 15 minutes, and we'll get back by when 12:25. Okay, we'll be starting before starting this next session. Gina's phone number I said. Hi everyone, let's start. All of you are here. Okay, sir. I hope all of you are joined. Actually, we set the time 12:25, and okay, ma'am. Let's start. So let's come to the core. That is EQuest. EQuest means the quick energy simulation tool. So this tool is developed by Department of Energy, as I mentioned earlier, and as this is a US software, everything is in feet, inches, BTUs and all. So the first task is there to convert everything from metric unit to this FP units. Let's see, and if you look into this particular website link I have given, you will get a lot of information about the software. As this is a free software, there is a forum running, and there are many experts there to answer your queries, and also you will find a lot of resources like tutorials and related linked components and all. So please go through this www. I'll post on the chat box as well, so that you may be able to go through later. After the class, you can have a look. And if we talk about EQuest, it has got a what is a low profile learning curve, we can say. It's comparatively simpler if you look into the energy simulation kind of softwares. And it is based on DOE2, as I said earlier. And you can build multi-level, multi-zone buildings with different kind of loads and different kind of occupancy as well. Occupancy in the sense if it's air conditioned or non-air conditioned. You can model different what do you say for that, different zones with different characteristics and multi what do you say building with multiple blocks and multiple floors. It's a flexible system. Some of the online energy simulation tools are available, but in that you will be able to design only one particular building, single building and all. But EQuest is free, but still in that you can do almost every task that is possible to do in other complex simulation systems. So let's come to the process chart. Step 1. What is the first step? First step is extracting AutoCAD drawing to, we have to reshape it and we have to convert it to the data set which is usable in EQuest. So how do we do that? Let me show you the procedure. First one. Okay. You can see my screen, right? Here what you can see is a commercial building. It's a simple building. It is having G+3 floors. This is a cellar floor which has parking. And if you look into this ground floor, you can see there is a retail commercial space. And there are 2 stairwells and one set of, toilet block. And there's a ramp on the outer portion. And in the first floor also it's a similar kind of plan, and second floor is also having same. So how do we Actually, in SketchUp, if you see, we can directly import this AutoCAD drawing, and you can draw on top of it and make the building model, right? Equus is also in a similar way. You cannot, Equus DXF format we can, or 3ds format we can open it directly in SketchUp. But none of these formats would be able to interchange to Equus. Rather, you can keep it as a reference and you can build your own model. Because as we said, in AutoCAD and this 3D Max, or what do you say for this SketchUp and AutoCAD and SketchUp, this entire drawing sets is identified as points, lines, and surfaces. But in eQuest, everything is identified in the form of a thermal zone. Thermal zone and component of that particular zone. So we cannot directly import the this geometric content from SketchUp or AutoCAD to the eQuest. But rather than that, we can keep a reference of this AutoCAD drawing and we can further create the thermal zones. So how do we do that? We have to simplify the drawing first. Here, if you look into this, you can see a lot of dimension lines and hash patterns I have already removed, but still there are level drawings and there are blocks like the toilet blocks and all those furnitures are there. So we have to remove all these things and we have to make our drawing simple. And then we can directly import to this AutoCAD drawing. For that, if it was on levels. So instead removing, as we received this drawing from an architect, as we received this drawing in a form like in a disorganized manner. If you see, the layers were not given in a proper way. So better than doing removing things, it's better to draw a new zone our own. So I am taking a polyline and I am going to draw this entire floor. All of you can see my screen, right? All of us know a polyline command. Just take a PL, click a PL or take the polyline and then just draw the polyline. Okay. So similar to that, right now you can see I have already done the periphery of the polyline. Now what we have to do? We have to design the zones with it. So for that, we have to see what we were thinking about. Perimeter core zoning is needed, or space-wise zoning is needed, or user-wise base zoning is needed and all. For that, we may have to look at the HVAC drawings as well. So in the HVAC zone, if they have given a centralized system for the entire floor, then it's easy. We can take the entire zone as one single entity. And then we have to differentiate according to the use. We can see, okay, stair room is there. So it's a different one. And it will be unconditioned as well as it's a public building. So we have to draw another zone. And whenever you draw, please make sure that you're drawing using polylines. Because other than normal lines, your drawing will be clear in eQuest when you import. Because in eQuest, all edges should be touched. Here, if you see, you can see a kind of void, right? But if you import this thing into eQuest, you won't be able to make the right geometry in eQuest. So everything should be closed. To make sure that, always use polylines. And what else? So after creating, I can show you one SLD that I have already created. In this, we simplified our model and we have just kept a single line diagram. Because in AutoCAD, we are manually drafting and showing, okay, this is the wall and this is the thickness. But in eQuest, we can directly create a single line and we can give the command for the software to build the wall. So it will build a wall. To, keeping it as a center line, it will build a wall. Okay. So after drawing the single line, you can see some more lines in my drawing, right? Some red lines. So what are they? Actually, they are reference points I have given for the openings. You look into this. CW1, W1. Actually, here is only one type of opening has been given. So to understand where the opening starts, where it is ending and all, I kept that kind of marks. So this will be easy for us on eQuest. Otherwise, eQuest identify based on SketchUp, you can directly zoom and click the wall, right? But even in eQuest, it's not possible. eQuest identifies by your input. It identifies on your wall elevation, what is the X coordinate and Y coordinate, where to place the window, and what shall be the height and width of the window. So those kind of inputs has to be given in a tabular manner. So this is the first thing. First step is simplify the AutoCAD drawing and make it perfect for uploading to your eQuest. And one more step is there. Whenever you do this, make sure that you are moving that particular drawing towards the origin. Okay. So how do you do that? We are keeping it and we have to try 0, 0, 0. Okay. So now this drawing is on the origin. I think it's due to some graphical error. It's not exactly showing over here. But if I type a line starting from, how can you understand that these are simple logic all of you must be knowing. I'm trying to draw a line from 0, 0, 0. Okay. See, my line starts here. So this is my origin line. Now I have to save as this drawing. Save as in which format? I have to save as this drawing in 2004 drawing format. You don't exactly have to make it into DXF or something. DWG works, but make sure that it works only 2004 or below versions. So make sure that drawing SLD 2004. I'm saving this file. Okay, let's come back to our next step. So first step is AutoCAD zoning. Zoning we have to do according to the principles that we discussed in the morning. And when you do, after doing it, make sure that you are saving it in AutoCAD 2004 format. There are some questions. Can't we import whole AutoCAD drawing and make a center line in eQuest for modeling purpose so that openings are more clear? You can do that, but if you import complex model to eQuest, sometimes it will get hanged. Because this is a free software, you have to carry that in a delicate way. Otherwise, your model will get crashed in between. It happens a lot. So that's why if you are doing large buildings, this is a quite small building, you may be able to do that perfectly. But if you do some large building which is having some 75,000 or 1 lakh square feet of area and which is having some 10 floors, you won't be able to survive. So the second step is weather data. So what shall be the weather data? And how do we get it? What can be the format that is supported by eQuest? We generally take weather data of .bin format, okay, for eQuest, .bin. I have already shared one weather file with you, and apart from that, I shared a folder. I think in the drive, you would be able to find this folder weather. And in that, a list of all Indian cities are given, weather files of all Indian cities in .bin format. So you may use this for your future use, or now itself you can. So from this, we are going to work on this IND Trivandrum 433710. Now let me tell you how to take this weather file. For that, there is energy plus weather file data is there. So either you can directly type energy plus weather data, or you can type energy plus .com, energy plus .net. You will get this particular website. So in that, almost, under this, under this Asia, because all continents are listed there. All continents and weather locations across all over the globe is listed. And from the list, I am showing you how can we take something from India. So take Asia, then India, and then there will be the city files. So after clicking on this file, they will ask you which format do you need. It has TXT file, DDV file, EPW file, and stat file, or either you can download all. So here, our .bin format is directly not available in Energy Plus website. So generally, we download the EPW, and there are weather tool converters available. So we can convert it using that weather tool converter to .bin. So the list I gave you is including all the converted weather files. The weather converter is also freely available. It's easily available, which is there on the data. Anyway, I will do one thing. I will post the link of this website as well for your reference. See. And if you download this TXT file, and you will be able to extract it using spreadsheet for your other, analysis purposes. So this https energyplus.net, this is a website. And let's go to the next step. Okay, so after downloading and ready, we have to go to the wizard mode. Because program works on two modes. One, that is the idle mode. And after doing certain basic things in wizard mode, we have to shift or tilt to detail mode for more complex inputs and more complex analysis. So in wizard mode, we can give basic information about building shell, internal loads, air side HVAC, and water side HVAC. There are 4 tabs. And in detail mode, you can edit whatever information has been given in the wizard mode to make it a little more, technically appropriate. So this is how it works. So in wizard mode, we generally do the zoning, that we will create this thermodynamic zones, geometric zones, everything. And then we'll give the floor height, the orientation, weather data, and window insertion also we'll do it in the wizard mode, and overhangs and skylights. So these, 4 basic things you have to do anyway in the wizard mode, because doing these things in detail mode is more complex. And apart from this, you can do internal loads, building shell, air side, water side informations also in wizard mode, but in a basic manner. So I'll recommend you to do, the basic of the envelopes in the wizard mode, and rest of the things we can do in the detail mode. That is an easy workflow that we follow, that I follow. That's why I recommend you to do so. So while working on the project, you may get an idea. And in the detailed mode, technically we are, generally we are changing the technical information that we were discussing about U value, this associated with building shell. We'll be changing the schedule U value and of other glass as well we'll change. And in the internal load, we know what are the loads, okay? The plug loads or the human loads, the occupancy loads that we have. And the lighting power density, equipment power density, infiltration aspects. And HVAC system. Okay, so there are two types of HVAC system. We know that it has air side systems are there, water side systems are there. So these two things will be modeled in two tabs in eQuest. That's why I kept it as two separate options. So if it's an air side thing which is having air side components, so you have to model it over that tab. And if it's an water side thing like pumps, chillers, everything, you have to model it in a different. So in the wizard mode, you will get this general information footprint, all these things. And as we said, we change the floor height north and we will draw zones in this manner. So we'll do it in our own, then we'll have a better idea. Okay. So after doing this geometry, let me come to the window. Okay. So let's start working on it till this point, and we'll explain the rest as we, on a step-by-step manner as we go. So let me ask you one more thing. How many of you already installed the software in your system? Likes, many likes. Very good, very good, very good. Okay, I got many thumbs ups and it's nice. Okay, then, okay, let's, so do I need to show that if anybody is getting stuck with it? I've already shared a couple of screenshots for your ease of doing it. And if anybody is getting stuck, I will share that as well in the drive. So please do it. So once after installing the system, let's come to that. Now all of our ECUS related folders will be automatically saved in documents, my documents, okay? All of you able to see my mouse, right? Or do I need to make it into, it's in night mode right now. Do I need to change the mode? Is it visible? Okay, sir. Okay, then I continue. Okay, so all the ECUS files will be saved under Documents tab. So please click on the Documents. Actually, here I am having many folders. You will be having only limited folders. And find out ECUS 365 projects, ECUS 365 data. There will be two folders named ECUS 365 projects and ECUS 365 data. All of you having these two folders? Yes. Okay. So this ECUS 365 data folder is for the backup data that software takes while doing the simulation. So if you look into it, you will get an idea. It has DOE2 folder and it has the system files and it has this rate libraries and it has weather files. Okay. So ECUS generally takes by default ECUS take weather data from this particular weather file. So before starting our ECUS, before opening the ECUS, make sure that the weather file that I shared with you is there in your system under ECUS ECUS data weather folder. Okay, I'll repeat the step. Under documents, my documents of your computer, there will be two folders named equals 365 data and equals 365 projects. Data and project. All of you can see, right? Yes. So under the data, as the name says, okay, it has all backup data, like what is used for the calculations, even if it's high calculations. And so under that, there will be this tutorial folder. You can follow that folder and you may be able to find some resources, like some PDFs will be there. Otherwise, I'll share you another PDF, which is a condensed consolidated data that it will have better, content. I'll share that as well in the drive. And so in the weather folder, under that, you'll find this weather folder. So please copy paste this ideal Trivandrum, whatever weather data I have given to this particular area. We have to do this before starting our request. So all of you are doing this, right? How many of you did? Please give me a thumbs up. Okay. Great. We have to save the TVM file in this folder. Yes, sir. Yes. We have to, because I sent you by mail as well the same file. Also in the drive, if you find along with the other weather files, you will get this one item. So please copy this from there, Control C and paste over here, Control V, that's all. So I assume that all of you have done it. Now let's go and find eQuest 365. And before that, let me tell you, and we found that eQuest data file, and there is one eQuest project file, right? So by default, eQuest files will get saved in this folder. Whatever project we create, we work on, it will be automatically get saved in this particular location. So, so let me start. Okay, this is the point I'm going to start. Please let me know how to get weather data from TVM. Actually, I've already posted a link on link over here. Either you can download from here, and yes, I'm posting that link once more. So I think you missed a part of the presentation. Okay. Otherwise, you can use the weather file that I already gave. Fine. So let's simply go. Please find the eQuest application. So whenever you install eQuest, there will be this eQuest refrigeration was also installed along with it. But we need to start eQuest 365, not the refrigeration one. So please make sure that all of you are clicking the app, eQuest 365 app. Double click or open it. You have to either download from Energy Plus. Actually, I have already given data of Trivandrum. Okay, erase everything from your mind. I'll show that after the class. I'll show once more because I think you people have missed some points that we discussed. So please follow. Please copy paste that Trivandrum weather file that already provided with you. Because we have only a limited time, right? So we have to complete everything in this. So all of you should be following me for some, for the coming 15 minutes at least. Please stop whatever you are doing right now and please look onto my screen for some 10 minutes and then we'll go back and we'll do once more. Okay, so I'm going to start. So once we open eQuest folder, eQuest application, there will be a window, eQuest startup options. You can see this, right? eQuest startup options. So from the startup option, they are asking us open a recent project or select an existing project or create a new project or generate SkyCalc weather file. So that's a different option. Here, for creating a new project, we know we have to click on this create new project by wizard. If you have a a data file in your computer and you want to open that, then you have to select existing project to open. Don't double click and open like whatever other files we generally do. Sometimes it get crashed. So it's better to open eQuest application first and then open the file or create a new file. So that's the procedure that we'll get, So after clicking on that create new file, there will be again two options. This is the wizard. Which wizard you want to create? In the slide, you must have seen wizard, right? So first of all, we will be working on the wizard. So the first wizard is schematic design wizard, and the second wizard is design development wizard. So generally, the schematic design wizard is something we use at the very initial stage of the project, like in the concept stage or something. If you click on that, you will get certain general information, and you can fill like we are going through the same information in the later tabs as well. So I'm not explaining a bit. I'm just simply skipping it. Let's see. So if you do that and click on it, click on finish, then your wizard screen will generate a model. Because there will be a default model. If you see that project 28 default. So it came to the wizard screen mode. Now let me show you the second option. How is it looking like? For that, I'm again clicking File New. Yes. That is a design development wizard. As I said, please make sure that you are you know the difference between these two. Schematic design wizard is a schematic one, as the name says. It's we use it in the general initial stage of design, and if we have everything with us, because there will be a lot of default values, we won't be able to change it. And click on design development wizard. So today onwards, we'll be working on design development wizard, and by the end of the session or starting of tomorrow's session, we'll change to detailed editor. Okay. So after you clicking on the screen, what is the first window you are getting over there? It is the general information tab. So in the general information tab, you can give the name of the window. General information tab. What is the project name? I'm writing FDP1. FDP project 1. Okay. So what kind of building is this? That's the second information. Okay. So here it's a retail building. So let's see, a retail building of 3-story with underground floor is here. Okay, here is a retail department store, retail large single story, and retail single story strip mall, service station, warehouse. Actually, this is a retail textile building. So that particular item is not listed over here. So in that case, we can go to unknown, custom, or mixed use, the last option. Unknown, custom, or mixed use, last option. Which option? You are in the first option, right? Design development and schematic design. So you have to take the design development option. So once you click on the design development option, you will get this general information wizard. Okay, please give me a thumbs up. How many of you opened this design development wizard screen? How many of you clicked? Can we not use this software for a residence? You can do it, no problem. You can do it for a residence as well. But ECOS just generally, advisable for air conditioned, completely air conditioned projects. You can find out non-air conditioned spaces as well. But still, you can't do CFD analysis or, wind flow kind of analysis in the ECOS. Other than that, you can find out what is the cooling load which is or heating load which is happening within the space, and also you can find based on the temperature set points as well. So that way we can finally say whether the space is coming under the comfort range or not, both in the case of natural and air conditioned spaces. But if as the systems are as air conditioned spaces are having more complex systems, you can model all these systems in a perfect way in ECOST. So otherwise, for unconditioned spaces, we have to keep many things on default. We may not be able to make exactly like the actual conditions. Which software can be used for thermal comfort residence? Okay, you can go for IES, or you can go for design builder. That directly you can go for those kind of softwares. Otherwise, you can go for some kind of adaptive comfort model by checking the results from AICTE and analyzing your own. After getting the zone data, you can analyze your own and prove the thermal comfort. As if you want to directly get it, go for this IES. Okay, so let's come to the chats after some time. So I think all of you are following me. So we change two entries. One is the name and second one is the use, unknown, custom or mixed use. And let's come to the important and third option, that is the climate. So for changing the climate, you have to click on this drop down and find out user selected, because it's by default it is California title 24. So we want to change it to Trivandrum, okay, the weather file that we keep. So click on user selected. Now you must be having a field to choose your weather file. So click on that and you can redirect to the folder like documents equals weather data. Actually, where did you copy that weather data? Just get the path of that particular folder and please redirect towards that. Mine is there in EQuest 365 data. So we have assigned weather as well. So we changed 3 entries now. Actually 4 entries and 3 inputs. And this jurisdiction kind of thing, we don't need to change it as of now because we are not doing for any kind of default compliances. Because if you want to do everything based on ASHRAE and all, you can click on that. But here we are going to put our own inputs. So we are keeping our other. And for electric and gas, actually we are not working out on rates. Generally, when we work out on energy modeling, the expected outcome that we are expecting is energy consumption in kilowatt. Because we were discussing about EPA, right? What is EPA? EPA is the energy performance index. So that has to be found out. What is a major parameter involved? It is the total annual energy consumption of a particular building in kilowatt hour. So we are doing whatever things we are doing. Okay, we are keeping the intention of getting that final energy targets. So please click on custom and or none. Please click on none. We don't worried about all these facts right now. And analysis here you can keep any year. Let it be 2021. And click on this prevent duplicate model components, because sometimes if you by mistake if you give more entries, like it will create duplicate components. And click on next. So before clicking on next, please give me a thumbs up. How many of you completed all these entries? We change the name, we change the use of the building, we change the weather file, and we unchecked the utilities and rates. Because it will make your model more complex. That's why we are keeping it none. We don't need that factor for finding out energy consumption or EP analysis. We are simply closing it. No more thumbs ups. Yes. Yes. I think I may have to wait for a little more time or what. If you have any queries, please ask. You could not upload the weather file. Upload in the sense you copied and pasted weather file in C documents. So please go to documents. Equals project data and check under your weather folder. No. Done. And Sika ma'am, please check this under the weather folder. You have already pasted Trivandrum or not? Yes, done. If you have pasted, you will be able to redirect. After pasting that, we can go to this particular option. Click on this building jurisdiction, click on user selected, and then we can redirect after you by using the 3 dots. This is like any other software. Like if you want to redirect or define some particular path, there will be the same thing. Fine. Okay, so let's go to the next screen. I have already an railway version is also asked the building. Okay, skip it. General information. General information tab. I am still there. Oh, okay, fine. So when you started, there will be 2 tabs, right? There is a schematic design tab, and there will be a detailed data edit tab. So you should have clicked detailed data edit, not schematic design. Detailed data edit. Schematic design is the one we generally do for concept level analysis. For detailed level analysis, we need to click the second option, which is detailed data edit. Detailed data wizard something, detailed design. Yes. Okay, so I think all of you are following me. Let me go to the next screen. So in the next screen, they are asking for the seasons. Actually, we don't have much seasonal variation. So we just need to keep only one. Or if you are working on some Western countries, you may have to add 2. And when you add 2, you can give that season 1 starts which month to which month and all. So I'm simply keeping 1. Okay. And in the next tab, all these things are for the project documentation purpose only. It's not mandatory to click. So please click on continue to navigator. There will be 3 windows you have to do. Please click on continue to navigator. Do I need to show this again? Do I need to show this again? No. Fine. So I think all of you are in this wizard project navigator screen. Actually, our real work starts from the screen. Earlier, we were simply giving the general information, like the general project information. Now, we are really going to start. What exactly we have to. Okay. So before starting this, please make sure that all of you are having SLD 2004 with you. I've already shared on Drive. Let me try once more. Yes, yes. So how many of you received the file on SLD from the Drive? Because it must be on 2018, you have to convert it into 2004. Now I have converted one drawing, so I will share that as well for those who don't have AutoCAD in your system. So meanwhile, do you have any queries? James? Link Drive. I think the coordinator has already shared the link drive. I'll also try to share, but I'm not. Sorry, not that link. Yes. SLD 2004. The name of the file is SLD 2004. Oh, it's still loading, I think. Earlier SLD was in 2018 format. You can see my screen, right? It's still loading, and the name of the file is SLD 2004.dwg. Didn't get the file. Ma'am, I just uploaded it, so I think it's taking some time. So it will reach you in a few seconds. So meanwhile, do you have any, questions in, whatever we discussed till now? Really clear. Thank you. Okay, fine. But I think we need to go a little more, in a faster pace, because otherwise, I'm worried whether we'll be able to finish this exercise by tomorrow itself. Anyway, we are going to have a very small building. So in the small building, it has multiple zones. So you can try out all options within eQuest. And later, like, after some, after the class, you may be getting a, half a day today and tomorrow. So you can further explore, and in between, if you are having any issues, you are facing any issues, you can discuss with me as well. Yes, the drawing is uploaded, I think. Finishing upload. Yes, please check it. The SLD 2004 is successfully uploaded. Please click the drawing and you please copy somewhere in your desktop or anywhere in your system. So once after doing that, let's go back to eQuest. So right now we have given the weather file, we have given the type of building, and we reached to this design development wizard project navigator. So in the project navigator, we'll be giving the geometry, we'll give the openings, we'll give the properties of envelope, etc. So let's click on this building envelope and loads one, and click on edit selected shell, because this shell has been created by default. So we are going to edit that particular shell. So click on edit selected shell. And then we can give a shell name. In eQuest, shell means floor. Okay. If you say you have this shell 1, shell 2, shell 3, we can rename into ground floor, first floor, second floor, and all. Because shell is that which has exterior covering and which has a ground covering and which has a roof covering. So this is an enclosed space, a shell. So we are renaming it into ground floor GF. And we already given custom mixed use. And there is an entry named building shell area. This one actually we can keep it as default. No need to change it, because this is the extent of area. Either this is anyway we are going to give the geometric input. So area will be taken from the geometric input. It won't look into this the default area which is already showing. But these factors are important. You can see number of floors, above grade, below grade, right? See, number of floors. So we are going to have this entry. Number of floors above grade. Suppose we are going to build ground floor now. So how does the floor situate? Is it coming below grade or above grade? I'm sure architects will be very much aware about this, but somehow other engineers will have little difficulty in identifying. But architects and also civil engineers, because we mark ground level first. So we know what comes above ground and what comes below ground in a faster pace. So here, as we are building ground floor and it is above grade, we'll give 1. And if it was a basement floor, instead giving 1, we'll give above grade 0 and we will give below grade 1. So that's how it works. And shell multiplier. Shell multiplier is nothing. It is if you have shells of different, same plan, Suppose earlier we discussed, right? We have to design the ground floor, we have to design intermediate floors, and we have to design the top floor in a separate manner. And if the intermediate floors are having similar plan. So in that case, suppose you have some 5 floors and your 3 intermediate floors are having a similar kind of plan, then we can give a shell multiplier of 3 over here. Otherwise, our ground plan is unique, so we can simply keep it as 1. And daylighting controls. Daylighting controls as an option. Here we have to switch on it. If you have windows, okay, if you are doing an underground floor, you may not be having daylight exposure, so you can keep it as no. But as our floor is above grade and it has windows, we have to keep yes, because ECBC is mandating for daylight controls. And next important factor is the suffix, prefix or suffix, whatever you use. I generally use prefix, because then when a lot of space, you know, when you are doing a 1 lakh square feet building, which has some, you know, some 70 rooms in it, you will be easily able to segregate ground floor rooms by click on sorting. So that's why I use prefix. So I'm using the prefix GF for ground floor. Now I'm going to the next screen. See, here you can see the number of the screen and the you know, details which are there. So right now we completed 1 of 26. We are going to 2 of 26. 2 of 26. They are asking about the footprint shape. Actually, EQUES gives some kind of, you know, default footprint shapes. That L shape, H shape, U shape. If your building is of this shape, you can simply click on any of the shape and you can edit these dimensions over here. CX2, my X2 is some 150. So this is how you can rearrange a building. So these kind of things you can do for a conceptual analysis. But here we have a clear building plan with us. So what shall we do? We have to click on the drop down and select custom. Custom. Okay. Once we click on the custom, there will be a pop-up. And in the pop-up, they'll ask previously defined footprint. So this is our first drawing we are going to make. And there are no previously defined footprint. So we'll give blank slate. Okay. And then there is an option for CAD file reference, background image, you can see, right? So please click on that and import the CAD file like we do for any other software. Okay, you have to redirect it. Where did I save that? I saved it in MES FDP. So please redirect from where did you save it. Now it will take a little time, but you know, it will open, and the only entry that you have to give in this window is the units. Units are important. You can see this, right? CAD unit. 1 CAD unit is how much inches? As I said you, this is not in metric, so you have to convert. Actually, our drawing was in centimeters. So please click on centimeters. I think it was. Let me check that. Yes, it was on centimeters. So I'm changing it. I'm drawing origin in building model units. Okay, if you are changing this thing in one floor, you have to change it in every floor. As we already given our drawing, already moved our drawing to origin, you can keep that 0, 0. We can apply and we can close. This is the reference origin where our building is coming. You can see on the backdrop, right? See that now the building has been coming. See, has come on the origin 0, 0, and click on apply and click on close. So this is how the drawing reference we generally give to this eQuest. And all of you have done this. Please give me a response. We'll go to the next step then. All of you redirected to the AutoCAD drawing. Yes. Okay, sir, let's just go. So the we'll between. Fine. Okay, so let's go to the options. So on the top left corner, you will see some options, right? This tab. These options are important. So these are the only, windows that will give some response in this entire tab. So here, if you click on the first option, that shape, segment or vertex section. So this one arrow like option will be helping us to draw the entire zone pattern, and the second one will be helping us to zoom out and zoom in. If you click and move up, you will zoom in. If you click and move down, you will zoom out. Getting the logic, right? And this particular pan the diagram option is there, right? When you do that, please make sure that this is not selected. Okay. If you are clicking on pan and you are selecting the CAD drawing, means your drawing will move. You can see this, right? Actually, we already set it to the origin, but now we are moving it. So it should not happen, right? So you have to make sure that this thing is locked and you are panning it. And see what's next. Sorry, before that I have to go to CAD options again. This one is again for CAD option. I can click on it and I can edit. I'll click. So if you you have already opened a CAD drawing and it is not the right drawing. If you think that it's not the right drawing, you can use this option to change the drawing. Right now I'm doing that. Centimeters. And the third option is for if you just want to change the units. If you forget to change the units and want to change the units, you can click on that. And this one is in your CAD. If you are importing it as such from your this thing, you want to switch off some layers over here, you can do that as well. But as I said, it will make your model heavy. So it's better to have just this the profile. And this one is to view the property of the work plane. In AutoCAD, we know we have options like ortho, we have options polar, switching on, switching off, and all. So those kind of aspects we can change here, and also the precision of the picking of that particular node in AutoCAD. Okay, those kind of things we can change here using these. I'll show you. Snap ranges, snap priority, this grid resolution. So grid resolution is 3 feet now, and we can increase or decrease, let it be. And CAD vertex, I'm changing it into 1 feet or even 0.5 feet we can go. So how much you are reducing your this snap range, you'll get such precision when you are picking the point. Okay, if you feel that you are not able to pick certain point, the precision is less, then you can come here and you can change it. And snap priorities, like we have already imported this AutoCAD drawing. So if we want to pick the particular lines in that drawing, we can keep this as first priority. And generally we keep CAD first, polygon second, and grid third. Or you can even switch off the grid snap. Done. Okay, so these are the options, and this undo and redo are there, but it will not work in all cases, because it will just work only when you are drawing some polygon and only one step up and back you can do. That's not so useful. And delete vertex will be there when you draw something and you want to delete that particular vertex, you can select it. So these are the tools. Now let me show you how to draw. For drawing, this is the first tool that we are going to take, and I'm going to pick some vertex. See, this is the vertex I'm going to pick. So when you pick a vertex, this particular node will be in a blue color. If you click and drag, the vertex will duplicate. See? Vertex will duplicate. And this is how we have to draw the entire wall area, wall sections. See, if you feel that I'm not able to pick it, then I can go to the property and change the precision. This is how we generally draw. So if the node is blue, you will be able to duplicate it. And let me show you one more thing. If you click once more on that particular blue node, it will turn some kind of cream or white. And now please try to move the node. It will be changing its position. So it's getting moved. So for duplicating a node, you have to click and turn it blue. And for moving a node, you have to click it white. This is how it works. Okay, so please do this exercise and please complete the vertex. And when you do this vertex, and if you want to delete the node, this is the option. Okay. If you are working on it, please click and you can pick all these nodes which are drawn, because these are references for the openings. So it's better to have all those openings. So please complete the entire floor plate. And I think you can share images using the chat box, right? Is it possible? Or only chat? I think you can't share this. But I think, okay, you can share in the Google Drive. You please keep your name and please. So we should open references. Yes, ma'am. Yes, because why are we doing this? When we go to detail mode other stages, we won't get any reference of CAD. So at that stage, we may be able to keep this line on the wall as a reference, and we can keep the openings. Okay, thank you. And if there are lines too closer to each other, if you can keep an eye on it and later you can work further keeping reference, it's fine. You can omit one or two lines which are too closer. You can use these two tools. Otherwise, we won't be able to see how close the nodes are. So you can zoom in and then you can use the pan tool and then you can, click and drag. Click and drag. There are two small toilet openings as well. This is how we can. So you must be wondering why are we not looking into the zones inside? Because this is the footprint option. Okay, in this we'll be drawing the shell footprint or the entire floor plate. So in the second option, there is another option in which we can go through and we can draw the zones within it. So all of you completed this? Not yet. Okay, it may take a little time, but later, once you have done 2-3 times, definitely you will get that. You'll be skilled and you can do it fast. Manoj sir, yes. Okay, nice. Okay, so one person completed. So shall we move? Yes, there are many replies. Okay, so once after completing this, we have to click on done option. Okay, you can see a done option here, right? So save footprint shape changes. You have to be about the dialog boxes that you're getting, okay? Because you have to tell me what all things are. And I'm getting footprint shape changes, I changed, yes. So all of you got the same thing, or some of you got your footprint reference is not compatible or something? Two later, or can we move a line? Can we add points in between two later? You can do, you can move, or either you can add, you can move, see, you can move like this. And if you missed a point in between, you can click on this and you can click and drag and make it complete. No one is getting any dialogue, okay. You have to be sure that you are making vertex post intersection with another shape segment, okay. This happens when you click on two nodes, nearby, but it is picking up the same node. So you can go back to this properties and you can change this range value, snap ranges. You can make it into a small value and make with more precision. Says cannot create a vertex on point. Yes, all these commands are there because you are you are trying to pick the point which is already picked. That's the second thing. First one is on the intersection you are going to pick again. So make sure that you are going to pick on the same portion, and there will be something when you if you have done it on a clockwise manner. So I was waiting for that. Nobody has received it. It's fine because all of you were following me. That's a great thing. Okay, so if you have done on anti-clockwise manner, you will get an error. You should always do in anti-clockwise manner. Whenever do this, you have to move in an anti-clockwise manner. That's the basic principle you have to follow on eQuest. So all of in an anti-clockwise manner. So it's a very important point. Whenever you draw a zone, even if it is footprint shape or if it is in the thermal zone thing, you have to draw this direction. If you have done, move. Can we add points in between later? Later in the sense after giving entries, you can't add points in between. But after giving openings and all, if you change your points again, then your openings will be lapsed. So you can simply do like this. You one day, 2 day, and you can do it, no problem. But the entries that later on will be, won't take into account if you come back and do this, edit the geometry, basic geometry. Or else I can click done and I can come back and I can, if I'm in 2 of 26 window, it's fine. I can come back again and I can, or I'm in 3 of 26, fine. But if you go to a window like 5 of 26 and all, then it's not advisable to come back and edit. It will create an error. You won't get the right result. Right result is that you won't get result at all. You may be getting a command that you will have some error that is not advisable and all. Otherwise, sometimes you'll get a command saying your openings are not, taken into account. And the openings that you have designed will be deleted automatically. So keeping all those things in mind, make sure we are following these steps in an orderly manner. Do I click? You please click on done on the right bottom. So let's go to the next option. So first one, we created the footprint shape. Now we are going to do the thermal zoning pattern. on this, and similar to what we have done, click on custom and click. Don't forget to click on translate. Otherwise, in the preview, you can see some kind of distorted shape. Right? This kind of distorted shape will be created by the software in your system, and you have to click and delete each of that zone. So for avoiding that, remember to click on blank slate. Click on blank slate, then click on OK. Now we can see cream color, this impression of the footprint that we created using the same menus. Menus are not different, so click on that and we zone within it, thermal zone. So once after preparing one single zone, so we have to create the second zone now. For that, you have to click. You can see my screen, right? There is an option to create new zone. Please click on this. You can create the next zone. I'm just pointing out this option for those who haven't come to this point yet. Similar to that, we have to click on that create new zone and we have to do this analysis. Do this drawing complete. Is there any questions in between, or any of you are finding some difficulties? No more hands are raised and no more questions are there in the chat box. So will we have 4 zones in total? 1, 2, 3, 4, 5 zones. Yes. Yes, 5 zones. Yes. Because we are creating a simpler model because of the limited time. If interested, I can give you one more complex model so that if you are ready to work afterwards, we can discuss that as well if some of you are interested. Because in this model itself, we'll be able to explore all the options. Anyway, it may take a little time for doing entries to if you are having more number of zones. So after clicking on create new zone, we can create all zones. Okay. Done. Okay. Done. Okay. So one person has done. Safia ma'am, it's a good job. And who all are there? Yes. Yes, I think I got many thumbs ups. So let's just go back. How can I go back to edit from here? Yes, let me see, sir. From here, you can again click on the three dots. You will be going there. And if you click on done, you will come back to the same window. So these three dots are there to access that work plane. Footprint edit. Okay, so let's see the next options that we are going to change over here. This is an important one. The first one is north. So let's go to the drawing and let's see how the north is located. See, the north is up on this building. Okay, so this end is the north. So when it comes to this drawing, north is down. So how do we rotate the north? All of you can see this north arrow, right? That I marked, north arrow. So how do we change the north arrow towards this down position? Here is an option, building orientation. So if you click on this particular drop down, you will get option to change our north. We click on this drop down. See, here we know the universal north is up. So here they are asking our north is down. That means our north is south. So we have to change that option to south. See, now my north is changed. This is how we rotate the north. In most of the softwares we may be giving an angle, but here instead we'll be changing the orientation name. So all of you are clear about it, right? So after changing the north, another important factor is the floor to floor or floor to ceiling height. Here, by default, floor to floor height is 12 and floor to ceiling height is 9. Let's look into the drawing. We are asking for CAD section, elevation and all, right? So this is the reason why we them. So here, let's see what is the floor to floor height and floor to ceiling height. Floor to floor height means from this floor slab to the top of other floor slab. It is 3.6. Floor to ceiling height is floor to this false ceiling, 315. As I said, we have to convert them to feet. So how much will it be? We convert 360 to 12, it is 12 feet, and 315 by how much it is? 10.5. So we'll have 12 feet and 10.5 feet. Floor to ceiling height. You're following me, right? One question is there. Yes, done. Okay, so we did north now, and now we change the floor heights. There are two heights mentioned. As I discussed, we know what is floor. We know what is floor to floor height and floor to ceiling height, right? See, suppose these many floors are there for us. Okay, so floor to floor, this height. Floor to ceiling will be this height. So we have to clearly mark them. So here, can you identify our first floor to floor height is green and floor to ceiling height is so do you know why you are following me, right? Is there any question? No question. Okay, can you guess the reason why do we have a green this thing? Yes, right, ma'am. Okay, as we edited it, it will turn to red. So by default, equals values you can identify by looking into the color. By default, equals gives you on a red, green color. Whatever options, if you go through the next options, we can see everything is in green color. So all of you edited this as well, right? Our floor to floor height is 12, floor to 10.5. So let's go to the next option. We don't have a pitch to. If we have a pitch to, you can give that, and by default it will create. We don't need to. Intersection, let's say it's okay, so click on next. And so here we were going to, we spoke about the building envelope information, right? What is the, material? What are the material that we are going to use? So let's come back to a little bit of theory. Now it's 2 o'clock. Actually, I thought of completing till this point today, not till this floor to floor height. One more point. Also, if we can spend some 10 minutes, it will be fine. Then after discussing that, we'll wind up today's session and we'll have tomorrow. So let me come to that. So are all of you okay with it? Can I take 10 more minutes? I won't go more than that for sure. Okay. So I'll show you this. So we discussed about the heat transfer principle, right? Because solar heat will be directly hitting on the surface of our wall, and a portion of it will be conducted, and it will be transferred to the indoor environment. So the resistance of a particular material, we know that will be hindering this heat transfer. So when it comes to the U factor is nothing but it is the overall heat transfer coefficient. Resistance, if you say in terms of one single building material, if you have one particular building assembly which is having a brick construction and which has some 1 centimeter plastering on both surfaces, and there will be an external effect of the airframe resistance, air film resistance. It can be if the solar radiation directly which is directly which hits the surface, and there will be the effect of the paint that you already coated, and there will be the effect of with the film of air which is immediately towards the plaster surfaces. So considering all these effects, we'll arrive at U factor, the overall heat transfer coefficient. So as you know, as the overall heat transfer coefficient lower, the heat transfer will also be less. If you can see the two sections that I have shown in the high, you can see on a higher U value side, the heat transfer will be more because it's a heat transfer coefficient. And this is measured in terms of watt per meter square Kelvin. So this unit as well, we have to, transfer to BTU per hour per feet square Fahrenheit. And we can do that. So this is how the concept of U value works. And if you see this particular wall section, you'll get a better idea. We are, we know the resistance of each of these materials, this plaster, brick, cavity, brick, plaster, everything. So we substantially, if we add that, 1 by R1 plus 1 by R2 plus 1 by R3 plus everything together, we'll get that overall heat transfer coefficient. And similar to this, there is a property of roof. It also transfers heat. So by increasing the thermal emittance and the reflectance of a particular roof surface, heat transfer indeed matters, but along with heat transfer, roof heat transfer also works in the same way. Roof U value we can find out. And along with that, we have to be careful about the reflectance and absorptance of that particular surface as well. So these are the three parameters that we need to look while we work out on this, reducing heat transfers. And we know what are the general method we use. We used to coat using white paints or some kind of white tiles or high reflective index tiles. You must be knowing about it. So these kind of strategies are there to hinder it. So whenever we do this in a practical case, we have to give the same input in our simulation engine as well. So you should know what is the reflectivity of the paint, white paint that you are coating, or what is the resistance of your wall assembly or the roof assembly. So these kind of aspects has to be given as input. So let's go back to the software. Yes. So here, building envelope construction, roof surface. They are asking for roof surface first. So we are clicking on it. And there are some default surfaces, wood advanced frame. Because as this is a US-based software, they'll show the materials which is available over there. So we have to change it. And we can give a custom layer by layer construction. And using this, we'll be able to provide better this thing. This as well, we can give custom layer by layer construction. And now you have to select the layers. Now we gave custom layer by layer. Now we have to select the layer. What are the layers? We are going to create some layers. Create new layers. Construction name. I am giving We'll do standard case first, or else I'll give wall 1. When I gave wall 1, there will be a window pop-up. Here we are going to add the materials of the wall. I think some of us have worked on Revit, right? In Revit as well, we'll be giving the construction type in a similar manner. Like we'll add the plaster, we'll add the brick surface, and in between, is there any air gap? We can add that particular thing. So this way, we can add. So instead, library entry, we have to give specific resistance only. Okay, and here we can add resistance. See, actually, I have shared a Word file with you. This is also there in your eQuest. So if you click on that, you will see the resistance values written in that. 0.61. See, resistance. Here, actually, I selected a wall. This is for ECBC purpose. ECBC U value has to be met. For that, I have given for roof, brick bed coba plus EPS insulation plus cement mortar plus RCC slab. So give the same inputs in over here. Overall outline. So this is one way of working on it. And another way is like you can go to this thing, detail mode, and you can do the same category, same exercise. So once after putting the first layer, I can go to the second layer. What is the second layer? What is the resistance value? Sorry, first layer is 0.681. 68. Second layer. .93. That this is not roof, right? Sorry, this is wall. This is a roof, but I named it wall, so you can change the roof. Okay. The first entry is roof surface, and the second one is wall. Both are here. Second one is wall, you can see, right? Above grade walls. See? This is wall and this is roof. So please change the name to roof, and you can add that after looking by referring to that Word file I gave. You must be facing some issues for, when you switch the screens. You may be you may be using what is it, mobile screen and this laptop together. Then you will have a better understanding. And I think for tomorrow, if possible, please arrange 2 systems or 2 screens. Like just a screen will do, because when we come to the HVAC part, there will be a lot of entries we have to change in between. So if you lose at one point, means I have to explain again, and it will consume a lot of time from our end. So let me tell you one thing: if you can add all this material and make the entire thing, as an exercise for tomorrow, we can finish, we can wind up the session right now. Otherwise, I can wait till you are making this. This is very simple. You just make this layer by layer and click on it. You will get this entry. Once after clicking each of these layers, there will be the second option will be, there will be another select. So just and click on done. And after doing this, click on return after creating both these wall layers and roof layers. Okay, click on return to navigator. Please listen to me right now. So let me explain the process. I can do that. According to the Word file, there are 4 layers. Those are for roof. Yes, and there are wall layers after some. Did I miss? I think I added both wall layer and okay. Actually, for the wall layer, I asked to refer the code. No problem. Please make roof layers first, and then I'll show we check it from the wall. No, this is there. This is wall layer is also there. Actually, after this ECBC table, please go down. Please check. Page 40, please check. 40. Please check page number 40. Make it. And please listen to me now. Please listen for 2 minutes. And then you can work afterwards. Okay, so after completing these 2 layers, you have to click on return to navigator. You have seen that, right? Where did I click? I'll mark and show you this return to navigator on the right bottom corner, this one. Okay, you have to click on that. And after clicking on that, you have to click on finish. Finish on the right, this. You can see this, right? And after clicking on finish, your model will load it. So this will get loaded. After loading it, you can save the file. Actually, many tabs are opened in my system. That's why it's taking too much of time, and I'm running some other projects as well in between. You might, it may not take this much time in your system for sure. So please don't click on anything. Wait till it gets loaded, and click on continue. Okay. After clicking on continue, you can click on save. Control S. Or you can do save as well. File save as. And if you clicked on save, your model would have been saved on, on documents, equals, projects. We discussed in the morning, right? So it would have been saved here. FDP project 1. You can see, right? Because by default, if you click on S, it will come there. FDP project 1. Here is my folder. So, and let me tell you how to go back and edit again. So please listen here. This is the key. You can say the key to shift between this view mode and edit mode. So using this key, you can see actions tab here, right? See this action. Okay. Please click on that action. After clicking on action, there will be this building creation wizard. You can see this, right? So after clicking on action, click on this building creation wizard. There will be a warning, don't mind it. If you click on it, you can come back to the window. And again, we can double click on it and we can edit. So please do till this point for tomorrow. And afterwards, we'll take tomorrow. And tomorrow, so we have this envelope assignment will be there, and electrical system, HVAC system, thermal zoning and HVAC system. And finally, we'll create the result and we'll learn how to interpret the result for considering this energy conservation in mind. So yeah, once after coming back, you can do size. And also if you go back to previous section, you can change this as well. Okay. So shall we wind up the session? Please share the links. It's all gone while hands-on going on. Okay. Okay, ma'am, I'll share that. What is to be submitted for today's exam? I'm not sure about the exam thing. Let me discuss. And actually, what I'm expecting is all of you should do these two layers, that layer thing in the model for tomorrow. Sorry. So before tomorrow's session, please complete it. And meanwhile, let me post that links. Oh, today's okay. Okay, I thought that the link been requested. Okay, no problem. So I think all of you are able to follow me, and you were in a position that tomorrow we can carry forward with the next technical inputs. And shall we wind up the session? And in case if you have any doubt, please post on the link. Otherwise, we can wind up in 5 minutes.
To all the participants, we have shared the attendance link and the test link in the WebEx chat. The test link has also been updated in the WhatsApp chat. So what you have to do is just upload. You can draw the profile of the building, whatever was taught today. You can draw the profile of the building and take a screenshot, attach it with the Google form that has been given, and then just send it back to us. So you have time till tomorrow morning to do the submission, so you can work on that. Tomorrow also we'll continue with this session alone, session itself. So that it will not be a problem, I hope. And the attendance also, you have only one attendance for the entire day. The link has been put up in the chat box.
Yes. Tina ma'am, I like to add one more point because please ask them to do that layer part as well. If they can do that and click a snapshot of that as well.
Yes, you can do that also and take a screenshot and upload it.
Yeah, fine.
If you have any confusions, I have added Ashika ma'am to the WhatsApp group, so you can post your doubts in the WhatsApp group. It will be active only for these 2 days, so please make maximum use of it and study EQuest as much as possible. We understand the limitations, but try to do as much as possible and practice the sessions so far what has been taught. I'm guessing it will be a little bit more detailed tomorrow because today you have just got the basics. So today has been a lot more easier. So I hope you will practice what has been taught today as much as you can, right?
Yes, exactly. Yes, tomorrow will be flooded with data. So be prepared for that.
Yes.
Yeah. Okay. And if possible, please arrange two screens like you can log in your mobile and your computer as well. Okay. Thank you.
Exactly. Yes. Also, I hope you are all accessing the Google Drive also that we have given you. Ashika ma'am has been posting certain files in there. So please check that folder also. And if you have any trouble, let us know. If you have any trouble accessing the Google Drive or any files in the drive. So at this point, Ashika, thank you. You spent a whole day. Tomorrow also you'll be spending your time with us. Thank you for that session. We'll continue tomorrow with the same session. Also, the participants, thank you so much for all the queries that's been coming up. It shows that you have been doing it parallel to Ashika ma'am, and you have been practicing it. So thank you very much. We hope you keep up this spirit tomorrow also. Thank you, Ashika.
Thank you. Let's meet up tomorrow. Okay. Bye bye.
Yes, we'll meet tomorrow. Thank you. Bye bye.